We're going to be talking about checking expansion valves. Before we condemn an expansion valve, we must ensure that we have our 10 degrees of subcooling coming to it. Once we have the proper subcooling and we have proper airflow, then we can start troubleshooting the expansion valve. We're going to be taking the superheat reading by taking our suction pressure versus our suction line temperature to see where the superheat reading is. If you believe it's underfeeding, pull the sensing bulb out, hold it in your hot little hand, see if the valve starts to open up. You can put it in some cold ice water, see if it closes down. Exercise that pin and see if it starts moving. Put the sensing bulb back on the line and determine if it starts working. We want to always protect the valve while we're brazing that in and out with wet rags, and we want to protect the bulb anytime we're brazing around that also. Of course, we're going to change our dryers every time we open up a system. When checking bolt-in expansion valves, make sure that you check the screen that's in front of that valve, and that goes for cap tubes also. If the screen plugs up, it will look like an underfeeding expansion valve. If you replace the expansion valve, either clean the screen or get rid of it and put a dryer right in front of the TXV, and that will both clean and dry the refrigerant for you. Anytime we go low on refrigerant charge, we pumped our oil out, but there's not enough refrigerant velocity to bring the oil back to the compressor. You may or may not already have another component failure. So with the R22 being an older system and the price of that going through the roof, we need to look at other alternatives for the homeowner. Maybe getting them into a newer, higher efficiency system is a better option for them, cost effective wise and operating cost wise. Anytime we're brazing on a system, we should be flowing nitrogen. A good time and energy saver or money saver for you and your company is to use a flow regulator so that we can flow the amount of nitrogen into the system, displacing the oxygen so that we don't have that black buildup inside the lines. Okay, we're going to be talking about flow controls, such as reversing valves. On the reversing valve, I have my high pressure discharge line, high pressure, high temperature gas, and it's either being directed inside in the heating mode or if it's going to be directed to the outdoor coil in the cooling mode. To get the valve to switch over, we need two things to happen. One is to have 24 volts to the coil. The other is to have enough pressure differential to make that happen. If you come across a DOA reversing valve, get enough pressure difference to make that to switch over if it's stuck in the middle. To do that, unplug the indoor fan, unplug the outdoor fan, get a little bit of pressure differential. When you get about 50 pounds of pressure differential, it should switch over and make that happen. Also be aware of the routing of these wires. If I have the common wire, when I want to switch it over, I can unplug it. It's energized in the cooling mode, I unplug it, and it switches over into the heating mode. I always want to unplug the common wire. That way if it touches ground, it doesn't blow a low voltage fuse. If I unplug the hot, if you will, the orange wire, and it touches ground, you're changing a low voltage fuse or an indoor transformer if it's not fuse protected. I also like to route that so it's behind and away from the panel so that it won't touch ground and rub and create a problem. With the reversing valve, we've got high pressure, high temperature gas coming into the valve. That's being directed either to the outdoor coil for the heating mode or to the indoor coil for the cooling mode. This is always our true suction, which brings the refrigerant back to the compressor. Another flow control is a check valve. Check valve is a ball valve that allows flow in one direction only and does not allow flow in the other direction. In the heating mode, I'll have high pressure side of the system is going to hit this ball. It will seat at those ribs, and there is a inlet screen to these that needs to be kept clean. So we're changing our dryers when we're opening up the system. We're doing good refrigeration practices so that we don't have a plugged up screen in that check valve. In that heating mode with the high pressure on this side, low pressure on this side, as the outdoor temperature drops, you'll see frosting on this part of the valve. That is normal because it's below 32 degrees. So it would see some sweating or frosting happening. In the cooling mode, you'll have high pressure on both sides of that as the flow goes to the indoor expansion valve. In one mode, we're forcing refrigerant through this valve. In the other mode, we're going around that valve. Sometimes the check valves will rattle on startup or shutdown. To prevent that from happening, you can get a magnet kit. It clips on right where the ball will seat, and that magnetic force will hold the ball in place while that system is starting up or shutting down. The refrigerant flow, as it starts to move, will overcome the magnetic energy and allow the ball to move with the flow of refrigerant. As higher and higher efficiencies are obtained in SEER and HSPF, with higher SEER values, that's our cooling efficiencies, that'd be an indoor expansion valve, maybe an electronic valve. Our HSPF, in order to get that up, we're going to electronic expansion valves in the outdoor unit. Doesn't matter if it's indoor unit or outdoor unit, the same thing's happening. We're taking liquid line pressure versus liquid line temperature and feeding that into a board so that it can control our superheat setting. In order to test those, we'll take the manufacturer's charts, check the pressure transducer, the pressure versus the voltage DC. We'll take our temperature of the liquid line and compare it to the voltage DC read on the temperature sensor. This valve is attached to the electronic expansion valve board. There's a test feature that allows you to drive it open or drive it closed. You can take a jumper wire or the side of your nut driver and touch to the open position, and the valve will drive open. It will do it for a very short time because the manufacturer doesn't want to flood the compressor and damage it. If you touch it to the closed to end that open test, and then if you touch it again, it will go ahead and drive to the closed position. You'll be able to watch on your gauges that pressure start to decrease, showing you that that valve does indeed open and close properly.